Hey guys, welcome back. Let's go and move on with the new 6.5 section, finding real roots of polynomial equations. Here in front of you are vocabulary you want to jot down to help navigate your learning. Right, it's good to understand vocabulary as we're discussing these terms and as you're asked to explain what you're doing. Alright, so here we are. Factor this. We're looking back at this problem because the extra help might come in handy. Okay, so this is a review problem, difference of two cubes. Well, if I'm reading this, I should find a subtraction I do and two cubes. I got one but not the other, right? All that does is encourage you to look for a cube, and sure enough, as we discussed in some of our classes, 216 is 6 cubed. All right. Now, what's important here is to identify that A is this portion, right? And I'm kind of jumping the gun here, sorry. Now, we did talk in class that this identifying of the difference of two cubes should trigger this whole formula, right? Something in your brain should be like, yeah, didn't I, wasn't there something that we discussed about this? Right, because you don't have to remember the formula. Just kind of organize your thoughts. So why this formula again, or why these two formulas? Because it helps you factor what? A sum or difference of two cubes, which is not easy to do the long ways, all right? But it does require you a knowledge of what A is and what B is, and it's not that difficult, right? So let's go and identify what A is. A is this portion here. Alright, so I'm going to put 7x plus 2. And you also need to know B. Alright, and we know that B is this value here, right? Or expression or whatever. So we'll put it in there. Alright. Now, when it comes to factoring, all you have to do is literally plug into the formula. Alright. The purpose of the formula is to make your life easier. So we're going to take advantage of the formula, right? So I do have a cubed, b cubed. So now all that I'm concerned with is this portion here, right? So check this out. I need a minus b, right? This is just a skeleton. And then I need a squared plus, once again, a times b plus b squared. Alright? So I'm just going to substitute. Hey, it needs a up front. Put it in there. Then the formula needs a b. Alright? Put it in there. Hey, now it needs an a again. Alright? What else? Oh, it needs an a again. Right, it needs a B, and lastly it needs a B. Okay, it should not be any more difficult than that. Now all you do is perform the math. So here, okay, just like you guys know PEMDAS, right? You do what's inside this larger set of parentheses, and you got 7x plus 2 minus 6. So 7x minus 4. You can't do anything else with that, so you leave it as is, right? Now we have this situation here, all right? While we did discuss this in class, this is 7x plus 2 times 7x plus 2, right? So that's going to force you to have this situation. Okay? So this indicates that you must multiply through the FOIL method. If you're unfamiliar with that, you want to distribute each term here with each one of these. So 7x times 7x, 49x squared. This with this is 14x. Now we go to the other, or the second term. This one with this one is another 14x. And this one with this one is plus 4. All right. This here is just scratch work, so I can get rid of it in a little bit. All right. Now I need to continue with this here. So now I'm going to move along, and I now have this set of parentheses. Can't do nothing with it, next to another set of parentheses which indicates multiplication. So now I've got 42x. Okay, distribute this 6 there, I got 12. And lastly, I've got 6 squared, which is 36. Okay. Now this scratch work, which you can do on the side somewhere, I'll simply get rid of it. Alright. Alright. Now this guy's nice intact. I must keep in mind, what am I doing? I'm factoring, breaking things up in factors. This is a factor unto itself, leave it alone. Now this is, believe it or not, a factor alone. However, I'm going to clean it up. I'm going to combine like terms. So I've got the only one with an x squared is him. Who else has an x? 1, 2, and 3. Okay, so that's going to be what? 28 and 42 is 70. X. Got him, got him, got him. And these values have no x variable, at least not visibly. So we got 4 and 36 is 40, with a 12 is 52. Right. Done and done. We'll be looking at one more of those tomorrow. Okay, next. Solve the polynomial equation by factoring. Very much up your alley. So when you look at this, I'm really hoping you're thinking, oh, I gotta get the greatest common factor, which is correct. So let's go ahead and identify 3 as the factor that divides all 3. And what's the largest amount of x's? He has 5, he has 4, he has 3, so they all have 3. Alright, and after I divide that out, I'm left with 2 x's there. 6 divided by 3 is 2. And I'm left with an extra x. And 72 divided by 3 is 24. He has 3 x's, he has 3, so it's over. Done and done. But what? Equals 0. So now we do have an equation. Alright? Alright. So what's the next thing you want to do is you also want to have trained your brain since last semester to identify that this trinomial, okay, can be factored further. This is where you use the t-chart, right? ax squared plus bx plus c. I will not go into that here because we are eating up too much time, but I will kind of verbalize some of that. Now after you do the t-chart, which you're highly encouraged to do so, you do know that we jump into the skeleton, so I'll jump into it real quick. And long story short, 2 numbers that multiply to give me him should also add to give me a 2. So what comes to mind? Let's see here. I'm going to go with, since it's got to be positive, I'm going to go with a 6 and a 4. Now do yourself a favor and check that on a t-chart, make sure that I am correct. Now once you're this far, you have factored, which is what we've been doing for the last 5 days, but because it said equal to 0, and you want to always double check what were you asked to do, is we're not actually solving the polynomial. So it's very simple, okay? When does x make this equation true? Well, let's find out, right? If this equals 0, the whole thing is 0, so let's find out when that happens. Same thing with him, s plus 6. When? What x makes this true, and what x makes this true? Alright, let's do these two, which are a lot simpler. You're going to subtract 6, and x equals negative 6. You're going to add 4, x equals 4. And with this one, alright, let's go ahead and solve for x on this one. The first thing you want to jump at is the opportunity to divide by 3, which leaves us x cubed equals 0. And the next thing you want to do is you want to apply a common knowledge or a familiar knowledge, which is that the opposite of a square is a square root. Therefore, the opposite of a cube is a cube root. So we're left with x equals 0. And these here, we'll just use this to describe our solution set since we were asked to solve. Okay, is the set of, how can we do this? Let's not overcomplicate things. The set of all x's such that x equals 0, negative 6, and 4. right. All right, and as a reminder, this is set builder notation. Okay, so don't freak out. It's just good to have in your toolbox. I think we're going to stop there, guys. I look forward to questions, comments, and concerns tomorrow so we can wrap it up and be ready for Friday. Okay, thanks for your time.